and we're live.
Okay. All right. Good afternoon, everyone. I guess we're just early into the afternoon. Um, thanks for joining us for this lunch keynote. My name is Matt Cowell. I'm the CEO at QuantHub, and I'm joined here by Nathan Black, who is our CTO and Chief Data Scientist at QuantHub as well. And so it's great to be presenting here on workshop day, which is a day where everyone's very focused on learning, because that's an area that we're passionate about as well, and we'll actually be speaking about today. And so our focus is going to be talking about how we as humans learn and the corollaries between that and how machines learn, and machine learning and AI, and actually trying to incorporate that into helping all of us figure out better ways to learn, based on some of the learning science that's out there, cognitive psychology, but also some of the machine learning and artificial intelligence techniques. Just super briefly, a little bit about us at QuantHub. We exist to help solve this labor crisis. There is a pretty significant labor crisis due to the lack of data skills. The World Economic Forum has done some really good research, as have many others, on just the incredible skill gap across the workforce globally. 54% of the workforce needs significant upskilling. 800 hours on average needed by an average employee. And this isn't necessarily just to become data scientists. These are just general data skills or data literacy, if you will. And so at QuantHub, we have an upskilling platform and also an assessment platform for data skills, and with a mission for helping improve or be a catalyst for the data fluency of organizations and individuals all over the world. And so this learning and data skills are both things that we're passionate about, and so that sort of leads naturally into the topic today. And so I'm going to let Nathan introduce himself and kind of introduce the topic here of really human learning and machine learning. Nathan, take it away.
Yeah, so like Matt said, I'm Nathan Black, and one of the co-founders, CTO at QuantHub, and we looking at this subject. This is a kind of a passion subject for us, and kind of looking back over my life, my experience. I found that I've kind of played a been in dual roles of a student and a teacher for almost my whole life. Won't go back all the way to the beginning, but for my undergrad, I was studying music performance, and while I was studying, I was also teaching music, and started a music uh, lesson company, and was training students on guitar, bass, and mandolin, and so uh, after uh, I left the school, and I actually moved over to Japan, and found myself teaching English while I was learning Japanese. So once again, in a teacher role, in a learning role. After teaching English for a bit, I went to work for the University of Maryland, and started my master's in marketing and in data science, and found myself learning marketing and data science while applying it and teaching it to the team that I was running. So whenever we uh, whenever we got to Quant Hub, and Quant Hub was focused on hiring great data talent, and we saw that there was an opportunity to expand our offering into training, and using our platform to train data science and help fill those data science gaps, not only through hiring but through education. So it led me to kind of reflect on just education and pedagogy over my life, and what worked, what didn't, and uh, Matt has pulled up here some research. It's interesting to see. We came across some parallels, incredible parallels from cognitive psychology, where people were focusing. This study from Spitzer's from 1939, and you have parallels in cognitive science where people were also focused on trying to improve computer learning. How do you teach a computer to learn? And there wasn't a ton of crossover from the beginning, but you have the Spitzers, you have the on the cognitive psychology side, and then cognitive science side, you have the Arthur Samuels early on, both working on a very similar problem, just one for computers and one for the human computer, the brain. And so we, as we dug more into this, we started noticing that there were a lot of techniques, a lot of research proven methods that uh, that were coming out that are not being applied today. And so we set out for Quant Hub to not just build another learning platform that leverages traditional education methods, but to actually leverage the best, most efficient ways to learn. And we found it very interesting that those often paralleled the ways that you train machine learning or deep learning models. And so that's what this talk is about, is the parallels between those. And our hope today is that you'll come away with some tips and ways that you can learn better. So this is focused on learning to learn, but we'll cover a few data science or deep learning topics along the way. So.
All right, so we're basically geeking out on learning theory here and applying machine learning principles to how we can learn better. So what we're going to do actually is we're going to show sort of contrast between, I'm going to play the role of the dumb ways we as humans typically approach learning, and then Nathan's going to say how machines learn and how we should actually how we should incorporate that into our learning. And so the first one is, and I know if I could see all of you, I know I'm going to get a lot of head nods here, that typically when we think about learning, oftentimes we're learning for the purpose of passing a test. And so many times in school and even in courses we may be taking after school, we learn, and then we take a test. And so it's almost as if we're learning in order to take the test and to pass the test. And so it almost feels like that's the purpose of learning, and that we're going to take a test, and it's always at the end of 9 weeks, or at the end of a course, or at the end of a semester. So it's kind of always after the fact. And so Nathan, tell us how machines approach this.
Yeah, so in machine learning, this specific example is from deep learning, is starting with a test. So how do you train deep learning? How do you get started? You get started with a forward pass, and guess how much you adjust the weights before you actually do the forward pass? Zero, right? You just randomize the weights, and the whole idea is to just start a test and improve iteration. So it all starts with a test. So you're not trying to learn and find all these patterns and then run the test. Everything starts with that forward pass.
And so I always like to say that, and I know, and this usually gets head nods as well. When we learn for a test, we learn, test, forget. That's sort of the unfortunately the historical learning pattern. But the best way to do it is actually to test early and often, and even maybe lead with a test. Like what you're saying, Nathan, with the forward pass approach is very much a get into it, take a test, see where you are, and start iterating on the topic from there, and have it be much more of an active learning type of approach.
Yeah, that was one of the most surprising findings for me was that you actually, even before you start learning, that you actually go take the test, and a few things happen there. One, it's called the forward testing effect, where you actually are creating a spot in your mind where that information is going to live. You create a curiosity in your brain that whenever it does see the information and does consume the skill, the knowledge from learning material, that it attaches to that a lot quicker and sticks in your mind a lot better.
Yeah. So the second one is focused more on retrospection, and so as humans, again, the way we typically learn is building on the last topic, really, where we learn for a test. We typically will finish learning something and then we don't revisit it, and so we'll learn, take a test, and then we will miss things on that test. Even if we do well, we'll probably miss a few topics, but we really focus on the score and sort of what we did well, and we don't actually typically revisit the topic and actually figure out what we missed, why we missed it, and make sure that we understand those concepts. We just sort of move on to the next topic and just focus on the success we had on the test, and don't really revisit any of the content. We kind of move on to the next thing. And so, tell us about back propagation, Nathan.
Yeah, so the way machine learning, what we can learn from machine learning here is doing back propagation. So once you have that forward pass, you're measuring, okay, how well did I do? Where are the errors at? And you go back and look at what was contributing to most to the errors. So in back propagation, you do the forward pass, you measure the error, you go find the weights, the specific weights that are contributing the most to the error, and those weights then get adjusted, and the loop continues. So you just continue to do the forward pass and back propagation, and that's how you train deep learning, and that's how machines actually learn in that way.
And so beyond machines learning that way, we certainly learn more effectively that way as well. If we get, so the real takeaway here is to get more retrospective on knowledge gaps, and so treat it like an iterative process where you are testing and identifying. You always are identifying gaps as you're going, and then you're revisiting those concepts instead of just kind of skipping on to the next skill.
Yeah, Matt. What's interesting is that there's such a stigma around testing. Like we all get a little bit nervous whenever it's a test or a quiz. At least I do. And the whole idea of passing that midterm or that final exam and woo, I'm done.
Right, that's the outcome. Oftentimes people treat that as the outcome, right?
Right. It's just it wastes that opportunity to use tests like as a efficient learning tool. So that I find that this one is a very been a very effective in my own learning of, hey, start. It's very tempting to jump in, learn, but to start with a test and actually go back and focus on which points are my weakest.
Yeah, absolutely. And so another area, and talking kind of about how we approach learning as human beings, we typically tend to start in the details. So we take sort of a bottoms up approach. Maybe Quora examples. If you're searching for something, you search a topic and you get an answer all the way in the most details, as opposed to just sort of starting with a high level problem you're trying to solve. And so instead, we'll learn all of calculus, all of linear algebra, all of statistics, before we even focus on the problem we're trying to solve, or the general area we're trying to learn. And so that's how we learn in academia. That's how we learn typically in courses as well.
Yeah, one of the interesting things here, parallels with machine learning, is it tends to start from the top down, and so if you look at how deep learning is learning, often learns the general patterns first, and then treats it gets more and more detailed as the task gets specific. And so instead of starting with the minor and possibly irrelevant, maybe even noise, it's finding those general patterns that it can then build on, to solve the problem.
So the takeaway here, I guess, for us to learn more effectively just in the general course of work, Nathan, it sounds like we should be thinking about this more top down, starting with the problem that we're trying to solve, and learn just the details needed to solve that problem, not trying to learn via all the building blocks that are needed to solve all problems.
That's right. One of the interesting things here is, and we'll talk a little bit about it with transfer learning, but is not necessarily treating any topic as a new topic, but treating it as an extension of something that you already know. And so one of the nice methods here in learning science is the Adept Method, where you actually start with an analogy, even if it's not perfect. And so we tend to start with the technical side of things, but if you can develop that high level understanding first, then those technical details will make so much more sense, and you understand how they fit in to the bigger picture.
So is the sport analogy here, Nathan, is it, when you're learning, the game of basketball, the first thing, a lot of times, unfortunately, is the first thing people start teaching you is how to dribble, how to shoot, how to do all of these granular things that are sort of bottom up. You're developing all the components, when the best way to approach it is just to start playing. And then
Right.
you'll figure out to some degree, that's also the test first approach. You'll see where you're successful and where you're failing. And then you'll start building in those lower level concepts and things that are needed in order to play the game more effectively.
Exactly. Like you said, I don't know how many times I've seen that you search for how to become a data scientist, and you see these things pop up on Quora and Reddit of, you got to learn all of the calculus, linear algebra, like you're mentioning, and those things that's great, but you don't know how those things are going to fit in until you see the whole picture first. And then once you have that whole game in front of you, then the parts of it make sense.
Which actually is interesting, and kind of leads into another thing that we typically do when we're learning, is that we generally learn in a very componentized manner. We learn subject by subject in school or in training courses. We'll choose specific subjects to study, and those will be very much siloed subjects, or even chapter by chapter in a book or in a course. You'll learn sort of discrete topics without sort of recognizing the overlap, if you will, which is just kind of how we've always approached it as humans in terms of learning. But there's a better way, right, Nathan?
That's right. And so we're pointing here, or saw parallels with transfer learning and with data augmentation. But transfer learning is where you're taking a model that has been trained on to perform a different task, and you are adapting the specific parts of it to your task. And so this is really where you're getting into not treating it everything as a new task or a new problem to solve, or a new topic to learn, but drawing on what you have learned before, in order to and treating everything as an extension of that topic,
Right.
even if it's not a perfect match, even if it feels distant. Um, and then data augmentation. So whenever you're in a subject, instead of just drilling down and learning that specific chapter or that specific skill, is trying to reflect and see it from different perspectives. And so that's what happens with data augmentation, where you're cropping or you're blurring or you're rotating images. In this case, data to not just learn that the top right three is a three, but the what how else could a three look, so that you're not just learning a specific instance or memorization. You're learning the general pattern, or the general skill.
So really, the takeaway is don't start from scratch. Recognize where you have skills. I think one of the examples that we were talking about before we got on here is Dancing with the Stars. You oftentimes see athletes doing well in Dancing with the Stars because they're building on other skills they have and other knowledge they have, and you were even telling me, Nathan, about what was the other football example you were telling me about earlier? The Bear
Oh,
Bryant and the
oh
Alabama, I
yes,
believe.
yeah, that's right. We actually heard recently that Bear Bryant, coach for Alabama, he secretly had New York ballet instructors come in to teach his football players ballet, and so that's a similar thing where you go, okay, well, we can actually build on other topics and use the kind of interleave different topics and vary them to actually learn better than just focus on one topic at a time.
Yeah, which is different typically than the way academia or even the way we typically learn. Again, we learn module by module instead of sort of skipping around a little bit, which actually is a little bit more effective if you interleave those different topics. And another one is, and this goes back to we learn for the test. Part of the problem there is that we're really just focused on acquiring the knowledge. But at the end of the day, if you can't actually recall what you acquired previously, what good has it done? And so we're very focused on learning, really in acquiring more knowledge, and but being able to retain that and recall and use that knowledge is sort of not something we consider part of the learning process. What's really interesting at QuantHub, we actually, part of our solution drops skills into a forgetting bucket, if you will, and then you have to revisit those. And we've actually had customers say, and almost quote unquote, that, well, I don't really want to do those things that are in that forgetting bucket. I just want to learn more things. And so it's there's something about us feeling like learning new things is the end of the road, as opposed to actually being able to use those things in the future is really the only thing that actually matters. And but it's interesting how we just don't typically think of that as the learning, as part of the learning process itself.
Yeah, and back to deep learning, it actually leverages kind of that forgetting on purpose, by doing things like dropout, where it's saying, hey, allow some of this to be forgotten so that I can recall the general pattern, not just the specifics.
Yeah, and then also on the prioritized experience replay, right?
That's right. And so taking the time, like you were mentioning, Matt, that learning, uh, acquiring information is limitless, but actually remembering that and taking the time to reflect is and manage that information is where the real challenge comes in. This example borrows from reinforcement learning, where there's a technique called prioritized experience replay, and so you train your agent to go play some kind of game or solve a task, and instead of just keeping on doing the same thing and training it that way, that we found that actually taking some time to revisit those experiences that the agent had, and finding the ones where it messed up the worst, again focusing on the weakest parts of your learning journey so far, and then using those to recall the parts that you need to really work on, and so then you can play the game better the next time you go out.
Right. So actually, what happens then, and the key takeaway here is really spacing, the repetition and the recall of that information you learn. Because right after you learn something, like is shown on the graph here, you forget it very very quickly. So it's your forgetting curve is very a rapid descent in the information that you're able to recall. And so the idea is to space the repetition of topics, revisit those things, which is exactly the opposite of the way we've typically done it. As I mentioned earlier, we learn, take a test, and then we don't revisit the topic immediately, and what happens is we forget it very quickly. Actually, in traditional kind of long form learning, you forget 90% of what you've learned within the first month. And it actually happens much faster than that, but just within a month, you forget almost everything you learned, which sort of defeats the purpose.
Yeah. And we don't have to go too much into it, but the interesting thing is just the act of recalling information changes your brain chemistry and reinforces those connections to that information, because your brain's basically saying, hey, if I'm trying to remember this must be important information. And so build better infrastructure to that information. And so allowing things to be forgotten a little bit and then recalled is the most efficient way to manage the things that you've learned.
And is really part of the learning process. I think that's the fallacy to a degree, is that we learn and we think that's the end of the process, but actually, cementing that or committing that to memory is really to some degree the not the end of the process, but a part of the process that we just often don't think about. Last one is oftentimes we learn in labs. We don't learn in kind of a real world setting. We learn with clean data instead of learning with data more representative of what a typical scenario would be. So it doesn't represent kind of a real world environment, and this is the case in a lot of training, that's out there. Certainly the case back in an academic setting. But what do we know about that practice, Nathan?
Yeah, so you have certain things like we're a lot of you, I'm sure, are familiar with validation, and trying to generalize things that you've learned to the actual real data, right? You've trained your model, you've gotten really good performance metrics, evaluation metrics, and then you try it out on real world data, and how it does on that data is what really matters. And so the same thing is true. You go into a class, or you read a book or watch a video, and yes, the things that you did in there were great for you training your mind, but the actual ability to apply it really relies a lot on how close that training was to the real data in the real world, the real world application that you're learning that skill for. Yeah, again, you see this with whenever you're trying to train things like self-driving cars. If you try to just train it on like a video game, that isn't completely the same as a real world simulation. And so you see that the most effective is actually driving a real car, right? Having it be out there on the road and find the problems that exist with real world data.
Right. And so the key takeaway here is, and Nathan, I know this happened to you, is, when you first started learning Python, I think you told me that, you were learning it in a browser, didn't have to set up anything on your local machine, and felt good that you knew how to code, and then all of a sudden you had to try to do something on your own, and it's just, didn't even know where to start. And so, simulate, I think the takeaway here for those of us trying to figure out how to learn more effectively is simulate the real world in your learning environment, get more hands-on, and have it be a little bit more realistic environment than the sort of lab environment when you approach learning.
That's right, and this really goes to a lot of those lab type environments. They feel good. It feels like you're making progress. Feels like you're learning. What really matters is you being able to apply that learning outside of the classroom, and so making that if you're learning Python like I was, try setting up your computer to actually do what you need to do, rather than just learning it in a training curated, very clean environment.
Right. So just to revisit the takeaways, and then we'll definitely have some time for questions. The key takeaways after sort of geeking out on learning here is test early and often. Don't just test at the end. And think of the test as being a part of the learning experience, not a part just of the evaluation experience at the end. Get retrospective on knowledge gaps. Don't think it's over with that final test. Actually go back and revisit areas that you were weak, and make sure you refocus on those areas, and don't just kind of leave that gap there and not address it. Apply top-down learning principles. Don't just try to learn all of calculus, all of statistics, all of machine learning algorithms. Focus on the problem you're trying to solve and learn just enough to actually solve that problem, and then rinse and repeat with other problems. And so really start from the end in mind, start with the problem at hand that you're trying to solve, and learn enough to solve that problem. Think about other topics that build on those topics. Find the patterns in what you know, and apply those patterns to what you don't know, and start recognizing the sort of corollaries that exist between topics, sort of like we're doing here between machine learning and human learning. Build on that knowledge of things that you already know. Recognize on the spacing exposure, recognizing and make sure you recognize that the learning doesn't end. It's not over when you learn it. It's actually it's over when you it's what's never over, but revisiting it and recommitting that to memory is a critical part of that, and you do that by spacing your exposure to topics. So don't just finish learning and then not revisit it. Actually make sure you revisit it, because what's happening in your brain is you're forgetting it, and we all know this intuitively, but the way you make sure that you don't forget it as quickly is by revisiting it soon after you learn it and using it. So if you focus on using that information quickly, you're much more likely to remember it in the future. And then last but not least is get hands-on. So learning in a lab, there's to some degree a place for that, but it's more effective to learn in as real world of an environment as you possibly can, and then that actually that helps you really focus on applying what you're learning and not just learning it. And so I'll pause there and see if you have any questions. We're happy to answer. We're happy to answer questions here if they come up in the chat. I also wanted to mention that we have a cool feature that Amelia's added here for the conference is office hours. So we do have an office hours right after this, actually, at the Zoom link you see on the screen here. So we'll be on there after this for as long as people have questions. We're happy to be on there answering questions. But if you have any questions, just go ahead and type them in here, and we'd love to answer any questions you guys have. Yeah, I think a couple people are mentioning that we'd love to connect. Absolutely, we're on LinkedIn. I don't have our LinkedIn's here, but Nathan and I are both active on LinkedIn. Well, me more than Nathan. So happy to connect with you guys. Our emails are on here, so would love to. Would love to connect you. Nathan, actually, one of the questions is more real world examples of building knowledge of corollary topics. What do you think about that?
No, that's a good question. The one that comes to mind immediately is I remember whenever I first got into a manager role, and I was scrambling to go, okay, how do you actually manage a team, and was actually able to draw a lot on what I had learned from instrumentation in music. So instrumentation is trying to piece together all these instruments to make them sound good together and harmonize well together. And there were a lot of techniques that, instead of going, okay, music is this and management is this, that pulling from those methods that work really well studied, it really helped me in my management career.
And so it's really is it sort of a subconscious thing, Nathan, to a degree? Is just be aware that building on things that you've learned elsewhere is always just a part of an effective learning process, or is it a conscious thing where you kind of think about other areas?
I think maybe it's a bit of both, where you always know that you have a base to pull from, and then when I find it very, very useful whenever I am doing any kind of brainstorming exercise, to actually consciously think, hey, how would I solve this? How is this similar to any other problems I've solved in music, or when I was learning language? How can I draw from some of those things that were learned there to solve this problem?
Yeah, so it is a little conscious, right? I mean, that's a great example of when you're brainstorming. I think that's, I guess I didn't realize it, but I think the same way. I'm thinking of this sort of pattern of thought process when we're designing something for QuantHub or whatever. I think through that sort of pattern of thinking of engaging people. Like we focus a lot on adoption, right? Of trying to get learners to adopt the system, and you start thinking about corollaries in other areas, right? Of how people adopt things in all facets of life. How you get the psychological aspect of getting them to approach something. Yeah, it's interesting.
Awesome.
Couple real quick. I think we have like a minute left. Any books or journals or articles you recommend on this topic, Nathan? I know Ultra Learning is a big one that we love. What are some others?
Ultra Learning is probably the most accessible if you don't want to get super technical. Make It Stick, not to be confused with Made to Stick. Make It Stick is a really good book by Peter Brown. And then another one that I found really, really great was it's one of the great courses, the not not just my own opinion. That's the company with great courses. It's called The Learning Brain, and it dives into pretty technical details on learning science. It's long and it's deep, but it's very rich.
Cool. All right. Well, if you are so inclined, we'll be over on the Zoom link for just kind of casual chat. And if that doesn't work, I'm happy to connect with anybody on email or LinkedIn. I saw a lot of people posting their LinkedIn's here. Look forward to connecting with you, even if it's just whether it's understanding what we do at QuantHub or just kind of geeking out on learning and helping give people advice. We're happy to do either. So yeah, we'll be over there on the Zoom in a second. Thanks, everyone.